encapsulation and abstraction. Now, this essentially means that you want to hide the implementation details from other users or other programmers in our case, and simply present a useful interface. What that means is that you want to keep internal state private, you want to expose the behavior of the code, not the data, and you want to use things like properties and getters for controlled access, and always abstract away all of the complexity. Okay, so we're having a look at a pretty simple class here, a bank account class where we define some owner, we have some balance, and then we define some transactions. Now, it seems like what could possibly be wrong with this code, right? There's hardly any code here at all. But the thing is that with this type of code, it's actually too flexible. It allows us to do pretty much anything. And while we may know how to use this class correctly, another developer or someone implementing this bank account, right, or wanting to use it in their program may not. So you can see that we can, for example, have a negative balance, right? We can have some, massive value in the balance that maybe doesn't make any sense. We can corrupt the internal state by setting it to something that's, not a list. Again, if we're just writing this code for ourselves, it's not an issue. But if we wanted to provide this bank account to someone else to use, they can mess it up very badly. The point is, when you design things like a class that you intend for other people to use in the future, you want to design it so that it works exactly the way that it should work, and you protect against all of these weird edge cases like negative balances, right? And, corrupting the internal state.